In calculus, a lot of times you'll run across, applied optimization or this idea of optimizing the amount of product you could get from a certain product, right? How many stuff, like what's the maximum, area or dimensions we're talking about you could get from, I don't know, rectangle. Could be all sorts of things. So let's read these problems together and try to figure out what they're saying. So this problem says a rectangular field is to be enclosed by a fence on three sides and by an existing fence on the fourth side. Find the domain of x, which we really don't care for. Here's where we care for. Find the dimensions of the field with maximum area that can be enclosed with 1,000 feet of fence. Well, again, let's draw the picture. Let's see what they're talking about. We're going to have a rectangle. All right. By an existing fence on the fourth side. So on the fourth side, I could probably have the fence here. Right. And again, this could be X, this could be X, this is Y, right? Find the dimensions with the maximum area that can be enclosed by 1,000 feet of fence. So it should be helpful to know that this 1,000 feet corresponds to this whole three sides here, right? The fourth side has a fence, so this is automatically cut out of the domain. So we could set a ratio of the perimeter to be equal to, okay, well, we have 2x plus y, and that will just simply equal to 1,000 feet of fencing, right? Again, it doesn't matter. You could have, flipped this the other way and had, you could have had it all the way, right? And it had like 2y plus x. It doesn't matter. It will give you the same answer. So once you find your perimeter, we know the area of a rectangle is just x times y, or in other words, your base times your height, right? It doesn't matter. I just prefer to use x and y because, math is mostly x and y, but it doesn't matter. You could choose base times height. Doesn't matter, right? I'll give you the same thing. I could put this as, B and B and A. Doesn't matter, right? So the area of a rectangle is always your base times height. So what you want to do is you want to solve for y, or you could even solve for x. I'm going to solve for y because it's much more easier. And then you're going to plug it into your formula, right? So y here will just be 1,000 minus 2x. And I'm going to drop my units here for a second, right? So my y is going to equal 1,000 minus 2x, right? So all I do is just plug this y in here, right? Because we want to find the maximum area. We can't take the derivative with two variables. So this is why we have to solve for y or x first. So once I do that, well, my area is just going to be equal to x times this whole thing, which is y, which will just be 1,000 minus 2x. And immediately this eliminates our two variable settings, right? Now I could go ahead and distribute. And this will just be 1,000x minus 2x squared. After you've reached this step, you want to take the derivative. This is when you take the derivative. So a prime now will just be 1,000 minus 4x. And then you want to set your derivative equal to 0. The reason why you set your derivative equal to 0 because now you're looking for that maximum possible area you could get from your x value, and then you could use that to solve for your y value, right? So moving everything over in one side of the equation, your 4,000, well, your 4x will just be equal to, or maybe I should put it on the other side. 1,000 is going to equal to 4x, right? Divide by 4 on both sides, and you get x to be equal to 4 divided by that is what? 250 feet. All right. So this is a maximum area you could get with this x value here. X will be equal to 250 feet. All right. So how about y? We're asked to find the dimensions, right? The dimensions, which will be x and y. So we already found x. So all we got to do is just plug this 250 in for y in this equation where y have, and we'll get our y. So again, y now will just be equal to 1,000 minus 2 times 250. All right. And that will just be equal to 500 feet. All right. So these are the maximum, these are the dimensions of the field that would provide the maximum area needed, right? And it should make sense. These values should not match at all because we're dealing with a rectangle, right? So our x are usually smaller, y is usually bigger, right? Your base is usually longer than your height. All right. So let's tackle another one. So suppose you have an open box. An open box is to be made from 3 feet times 8 feet rectangular piece of sheet metal by cutting squares of equal sides from the corners and bending up the sides. Find the domain of x, the side of the squares. Find x that will maximize the volume. So the first thing I like to think of is to draw a picture. So we're dealing with a rectangular box, and we're kind of cutting out squares on each side, right? So we're cutting out squares. It's cutting out squares on each side, right? Now we're gonna find x that will maximize your volume. So if we're cutting out squares on each side, does it make sense that I could call these x? This is an x, x, an x, an x, an x, an x. X. There should be an x here for this one. All right, x here for this one, x here for this one. All right. So basically, if we're trying to maximize the amount of product we can get from this rectangle by cutting out these squares, we're cutting out x's, right? We're cutting out x's, right? I'll just call these x's, right? So really, right, the volume of a rectangle, right, that is just base times height times base times height times length, right? All right, base times height times length. Right, or the base times the width times the height. I'm tripping. Base times the width. All right, so this should be width. All right, base times the width times the height. All right, we actually don't know the height. Right, so this will be our x. We really don't know the height. We know what our base is and we know what our width is. Right, so our width is here. Our base is down here. Right, so how can I tell that I know what my width is and I know what my base is? Well, again, my width is going to be, well, again, if I'm cutting out 2 x's from here, right, it tells us that this is 3 feet by 8 foot. So again, it should ring a bell that this side should be equal to 3 and this side should be 8 feet, because again, we're dealing with a rectangle. Your smallest side will always be your kind of length, right? The smaller side will always be your length, and your longest side will the longest side will always be your length. Well, the longest side will always be your base. The smallest side will always be your length, right? So this is length times width times height, and I have a base here, so I'm tripping. So this should be length times width times height. This is the formula. So this is our length. This is our width. All right. Width is always going to be larger than length, so therefore wouldn't it make sense that our width would just be 8 feet minus 2x, because we're cutting out 2 boxes here from the length, from the width. All right, so that will be 8 feet minus 2x. Or length on the other end will just be, well, okay, this is just 3 feet minus 2x again, because we're cutting out 2 x boxes from that length also. So that will be your length. We know our width. We actually do not know our height, right? So now you want to use that same formula and plug everything in. So your volume is just going to be your base or your width, doesn't matter. Your base, right? So it'd be 8 feet minus 2x, and that will be multiplied by 3 feet minus 2x multiplied by x. This will be your height. This will be your base. And this will be our length, right? And all I'm doing is plugging in these values in for this formula here, right? Now we could go ahead and optimize and solve. So the first thing you want to do is distribute. So the volume now, well, 3 times 8, that's just 24. So I'm going to drop my units here for a second. So this will be 24, all right, minus 2 times 8 is just 16, x, right? Minus 2 times 3, negative 6x. And then negative 2x times negative 2x will be positive 4x squared, right? And this all will be multiplied by x, right? So your volume now will be, I'm going to just do everything here in one step. I'm going to distribute this x here. So this will be 24x minus 22x squared plus 4x cubed, all right? As you can see, all I did was did everything in one step. All right. So now with that being said, I could go ahead and take my derivative. I'm going to rewrite this the other way because I know I'm going to have to solve. But let's take my derivative first. Right. So now that I have everything simplified, I could go ahead and take my derivative. So v prime will just be 24 minus, well, 2 times 22 is just 44x. All right. Plus 3 times 4, 12x squared. And all I'm going to do is set my derivative equal to 0 now. Right? I'm going to rewrite this in other terms. Right? So this will be 12x squared minus 44x plus 24. And that's equal to 0. Now here, you could see that I could, possibly simplify here and simplify everything by 4. So this will be 3x squared minus 11x plus, well, 24 divided by 4 is just 6, and that's going to equal to 0. Now we could possibly factor, right? So again, this will probably factor into 3x. We have a 3x over here, we have an x over here, right? And this all just comes down to simple algebra. So my factors should be same signs, 3, 1. All right, so this would be 3 and 2, right? All right, 3 times 2, 3 times 1. So once we find a factor, and you could go ahead and factor this on your own. This is just basic math right here. Once you find your factors, you set that equal to 0, right? So you can see that x will be equal to 3 feet, right? And then x will be equal to 2/3 feet, right? Now, which one do we choose? Well, we got to go back up to here and kind of find the domain. So what's the smallest amount of box you could cut out? Right? What's the smallest amount of box you could cut out? Well, that's going to be equal to 0. Right? If you cut out 0 box, you have none, and so that will be your smallest. Right? Your largest is actually going to be the half of the smaller side of the rectangle. It will be half of the smaller side of the rectangle. So the largest box I could cut out and still get 4 pieces of squares will be half of this 3 right here, right? So this will be 3 halves, right? So the smallest you could cut out is 0 because you don't have any after that. But the largest you could cut out is 3 halves. You can't cut out 8 halves and before that. Just remember that the largest you could always cut out is half of the smallest side. Always half of the smaller side. So with that being said, all we do is just divide 3 by 2, which is the smaller side, and that will be the largest we could cut out, right? So which one will maximize the volume? Well, 3 halves is around 1.5. So definitely 3 feet is not in the domain, right? Because it's way more than 3 halves. So that will not be possible. So your answer should be x is equal to 2/3.